With functions, it's always important to see their graphs so we understand how they behave. We also understand that we can transform these graphs by understanding a basic parent graph. This is a standard quadratic function, and this is the parent graph of a quadratic function. F of x equals x squared is the most basic of quadratic functions. You can see the vertex here at 0, 0. You can see that the y values do not dip below 0, so we would have a range from 0 to infinity, but these are infinite graphs, so it's going to extend in either direction to infinity, so our domain is all real numbers. Next we have a square root function, and this is the parent graph for square root functions. You can see that we start here, or the domain starts at 0, because we can't take the square root of a negative number, or more specifically, the square root of a negative number is not a real number. So our domain begins at 0, and it's going to go out to infinity. So the earliest number, or the smallest number we can plug in, is 0, which gives us 0. So we have a point here at the origin, making our range from 0 to infinity as well. This is a standard cubic function, f of x equals x cubed. The domain is all real numbers. You can plug in anything at all in a cubic function, and it's going to give an output of anything at all as well. So it has a domain and a range of all real numbers. And these are just a few parent graphs that you might be asked to transform as we introduce the graphing transformation rules.